Hello guys, welcome back to my channel. Trust we've been doing great, and we're following the concept of each task as it comes. In today's video we're going to be doing justice to recursion. I thought of doing a tutorial first for recursion, so that you understand the concept. Like I always say, this is why you are here, not just a task. So in today's video we'll be looking at recursion, introduction to recursion, and I will also be helping us to look at why you need to use recursion and when you need to use recursion. All right. Now, what is recursion? Recursion simply is a process in which a function calls itself, either directly or indirectly. A process in which a function calls itself either directly or indirectly. Okay, so how do I mean by this? So let's say this is a function, and let's call this so let's say int sum. All right, so let's say this is a function, and let's just pass a parameter and say parameter n. Okay, and inside this function we call the function sum again, just like this. All right, so this is recursion. When a function calls itself is recursion. So why will a function call itself, and how do you use this? Why will a function call itself? For instance, just to put this in perspective, let's say we are in a PLD now, a tutorial, and there is someone called Jessica, right? And I call Jessica. So if I call Jessica and Jessica answers me, I will stop calling Jessica because Jessica has replied, and I will tell Jessica what I want to, the information I want to pass to her, right? But let's say I am calling myself, and I'm saying I'm calling myself, and I'm supposed to answer myself, right? So I'm calling Emmanuel, 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 and I am me, so I cannot even come to me to pay attention to me, right? So I will keep calling myself Emmanuel, 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 Emmanuel until I will run to infinite call. That is, in programming, infinite loop. Now, for me to call myself and, not run into infinite loop, so I don't look like someone that is insane calling myself over and over and over and over again, I need to put a base condition or a terminating condition. All right, I need to set a condition and say, if I call myself 3 times, then so things should happen. Maybe I should stop calling myself because this has happened, or if I call myself 3 times, let this happen, right? That is what recursion is. So first, in recursion, note that each time you want to use recursion, there must always be a terminating condition or a base condition. There must always be a terminating condition. Whenever you use recursion without a terminating condition, then your program will run into infinite loop, right? How do I mean? Let's say, for instance, so let me take this off. Let's say, for instance, we have this. Okay, so let's say we have 4 factorial, right? Let's say we have 4 factorial here, and here, so 4 factorial will be 4 by, so 4 minus 1, right? 4 by 4 minus 1, which will be 3. So I will just say 4 by 3, 4 by 3, and the next is 4 by 2, 4 by 1, so 4 by 2, 4 by 1, 4 by 0, 4 by -1, 4 by -2, 4 by -3. So this condition will keep going and it will not get to the end. Why? Because there's no terminating condition. So for us to be able to have a terminating condition, so our program doesn't run to infinite loop, we will say once is equal to 0. So once, let's say n is equal to 4 factorial, we say once n is equal to 0, then the condition should be met. If not, it will run to 0 and then go to 0 minus 1, 0 minus 2, 0 minus 3, 0 minus 100, 0 minus 101, just like that and like that and like that. So your program will not stop running and your system will run into trouble. You will exhaust your system memory. All right. And for recursion, you use your stack memory. So you're going to run into what we call stack overflow. Okay. So just so we don't waste so much time because of our task, let's go ahead and look at what recursion is in proper terms. What recursion is in proper terms. Let's write a simple program. I hope this will help us do justice. Okay, this looks better. So let's write a simple program. Just to be able to explain this to us. Now I'm going to write this and then I will give us another form of writing the same program so that you understand what recursion is. All right, so let's write a simple program. So hash include maybe I should use the text box. I think it will be faster for us that way. And then we can explain it. Okay. So hash include stdio.h. Okay, so here let's create a function and call it so let's call this sum, and let's just pass a parameter and say a. Okay, so here let's call our main function int main. Okay. Now, inside our main function, let's just declare a variable and say this is equals to 3, and then let's call our function here, which is sum as declared here. So we'll call our function sum here. So let's just say our function here is sum. Okay. Now here where we have our recursive function, let's go ahead and set a condition. So we're going to say if now we're using a. All right, so if a is less than, let's set it to 1. If a is less than 1, if a is less than 1, return a. If a is less than 1, return a. Else printf %d and then now we're going to call the function again, which is sum. So here is where this condition comes, a minus 1. So now this is the function calling itself, and here we're going to say printf again %d, and then we'll pass in a variable a. Okay, so now let's look at this program. Let's look at this program. Okay, so here we declared the name of our function to be sum, right? So, and then we now call on our function again, sum, here. Now let's have this as our stack table. Let's say this is our stack table here, right? Now our stack table first, of course, is going to look for the main function first and call the main function. So let's say this is our main function stack. Okay. So let's say this is our main function stack here. All right, so what's going to happen is that it will call on the main function. So here we just say main. It will call on the main function. And then already in the main function, we called our function, our recursive function, we call it here, and we pass whatever is in the main function to it, which is, in this case, n, and n here is declared as 3. So what is in the main function is 3, right? Once it calls the main function, it will then go and check where is sum. Sum is here. So you look at sum, okay, fine. Pick sum, and then look at the condition. What is the condition? If a is less than 1. Now sum, is sum less than 1? No, sum is equals to 3. Sum is equals to 3, not less than 1. So what is going to happen? It will exit this condition and get to this condition. And this condition says if sum is not less than 1, then print a. And what is a here? A is 3. So here we are going to enter into our recursive function, into the stack of our recursive function. Sorry, it's supposed to be a straight line. Now, what is going to happen here? Our a is equal to 3, right? Equals 3 here. So it will call our function a, and then a is equal to 3 here, right? So if a is equals to 3 here, we're saying sum a minus 1. A minus 1 is what? A minus 1 is 1. So we now say printf. So let's pick the first one, printf. And printf here, a is equals to 3. Remember, I have 3 statements here. The second statement, which is sum. Now sum is a minus 1. A minus 1 is what? A minus 1 is 2. So this is going to be 2. And then the last statement is printf again, to print whatever the result is. All right. Now, it will not print this result because the condition is not yet complete. It has to check again, right? It has to check again and see if now here a minus 1 is equals to 2. So that means if we run it again, at this point a now is 2. A is 2, so here a is equal to, because a now exiting here, a now is equals to 2, so it will enter here. Is 2 less than 1? No, 2 is not less than 1. So what will happen? It will print again. So here it will print. And here what is it going to print? It will print 2 because now a is 2. So it will print 2 here. And here sum is equals to a minus 1. And a is 2, so that will be 2 minus 1. And 2 minus 1 is what? Equals to 1. And then printf. Printf. So it will check again. It won't print this. It will go back again and check because it's looking for this condition. Now, what is a? A is equals to 1. So it will go back again and check. Don't mind my table. It will check again. A now equals to what? 1. 1. So is a less than 1? No, a is equals to 1, so it will print again. So here it will print. It will print for us the value of a, and the value of a is 1. And here in sum, it will print again for us. Sum is a minus 1, and 1 minus 1 is what? Is 0. Printf. It won't print because the condition is still not met. It will go again and check. Now a minus 1 is 0. So it will check again. Is a, which is 1, 0, less than 1? Yes. So now a is equals to 0. And because a is equals to 0, this condition is no longer true. So what will happen? Recursion will take place. Now it's going to reverse itself. How do I mean by that? It's going to start running from here down. Now remember, we were going like this. So the main function checks and picks 3 and gives 3 to sum, because sum is declared here, all right, inside the main function. And it will check the condition. Is 3 less than 1? No, 3 is not less than 1. It will enter the else condition, and then it will print 3. Print 3 for us and check. Sum minus 1. Sum minus 1 is 2. If sum minus 1 is 2, it will not print this. It will go back again and check and see. Now, sum minus 1 is 2. So a now is 2. Is a is 2 less than 1? No. It will come back again and print 2 for us, right? So it will go and check again. Now, the condition is going to be 2 minus 1, which is 1. Is 1 less than 1? No. It will come back again and print for us. So it will come here. From here, it will enter and print this. From here, it will enter and print this. And from here, it will check for this condition. Now, this condition is true. Okay, it has met this condition now, right? It has met this first condition. Just look at this. So it enters 3, less than this, no, it will print. It enters 2, n minus 1, is it less than this? No, it will go until it gets to 0. Now once it gets to 0, it will then return back again and check. So here is the same function, all right. So now it's going to look again, the condition is met, then it will just print back a printf in stack. In this stack, a is equals to what? 1, so it will print 1. In this stack, a is equals to 2, so it will print what? 2. In this stack, a is equals to 3, so it will print 3. So now it's going to return to us here. It's going to return to us 3, 2, and 1, and then it will come back, it will fall back and check from here. It will print for us when sum is 0, is printing 1 for us because this is a stack for 1. A is equals to 1, it will print 1. It will check again, it will print 2 for us. It will check again, it will print 3 for us. So printf, it will print 3. So here you are going to have now printing 1, 2, and 3. So this is a recursive function. First, it will check for the condition, print out the condition for us, and then it will then print out the result for us. Now let's put this into a proper program. Let's go to our terminal and write this so that we'll better understand this. So we're going to use the same thing, and then we'll just write a program. So let's call this test 1. Okay, so here let's call our program. Let's use sum, and let's declare a variable. Let's say this is n, and then let's call our main function. We can say, we can use int main. Okay, so here let's just declare a variable we'll use. Let's say n equals to 3, and let's call the name of our function, which is sum, and say sum, and give sum as n. So we can say sum is equals to n, or sum n is the same thing. Okay, so here let's set our condition. Remember I said that for recursion you must set a condition. If not, then your code might run into infinite loop, or your program might run into infinite loop. Okay, so if n is less than 1, just return n, right? Return n to us if it's less than 1. But if n is not less than 1, that's else, else printf %g, let's give it a new line, and then let's call our function, which is sum, n minus 1. And printf again, %d, let's give it a new line character, n. Okay. So this is the program we just explained, right? This is the same program we just explained. So if by the time the main function passes 3 to our function, it will run and check for 3. And now that means for sum, sorry, that means n now becomes, sum becomes 3. It will check, is 3 less than 1? No. Since it's not, it will enter the next condition. And the next condition is to print n. So it will go ahead and print n, and n is 3. Once it prints n, it will check sum minus 1. And sum is 3, so that's 3 minus 1, and it's 2. It will enter the loop again and check, is 2 less than 1? If 2 is not less than 1, then enter this condition. It will print 2 for us. It will check again, 2 minus 1. Is 1 less than 1? No. It will print 1 for us. It will check, 1 minus 1 is 0. It will check, is 0 less than 1? Yes. 0 is less than 1. So if 0 is less than 1, then return n. Right? Return n. So it will check again, and then it will return n. And at this point now, n is in the stack overflow of 1, which is what printed it. So it will print 1. It will check again, return n. It will check the stack overflow of n. At this point is 1. The stack overflow of n is 2. It will print 2, and then it will print 3. So let's run this program and see. Okay, so this is our result. So you see, 3, 2, 1, 1, 2, 3. 3, 2, 1, 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. So this is recursive call. It calls himself, and then it will run and check. If the condition is not met, it will check the condition again. It will run again until the condition is met, right? Now, but this is a bit lengthy, you know, but I believe you should understand. But if you don't, you can just go through this video over and over and over again. I'm sure you understand. But let's do something simpler. Let's do something simpler. Here I will minimize this, and let me clear this too. So let's do something a bit simpler. All right. So let's say hash include stdio.h. All right, and here let's declare and say this is int, let's say 5, or let's give it a number. Let's say int a equals to 0. Okay, and let's call our function here, and we'll call it, let's call it sum. Let's call our function sum. So in sum, you can call it anything. You can call it total. So let's say in total, so that it doesn't look like it's sum we've been using. Int total, and then let's call our variable x. All right, so this is, you know, you already know what this is. This is a function parameter. This is a function parameter. This is the return statement of the function. This is the function name. Function name, function parameter. This is type. All right. So function parameter type. So if it's a character, then it has to be char, right? Okay, I know we know all these things already. Now let me go and declare my main function. So int main, and let's also initialize and call this int b. You can say int b. You can say int b. And then here let's call our function name, which is total in this instance. That's the function up there is total here. All right, so here let's pass a parameter. So we can say b, sorry, yeah. B is equal to the name of our function, and let's pass a number here. So let's pass a number. Let's say 5 or 4. Let's say 5. Okay. So we can actually say int b equals to 5, and then we'll call on total and pass b to it. It will still work that way, like we did in the last task. Like, what I mean is, we can say int b equals to 5, and here we can say total, and then we'll pass b to it. This is still valid. This is still very, very okay, right? So however you do it is correct. Okay, so this is our main function. Then let's go to our recursive function. So here we declare that int a equals to 0, and then let's give a condition. If x as declared is equal to 1, so this is a condition. Just return s to us. If x is equals to 1, then return s to us. And so let's give this condition and say a equals to s plus total x minus 1. Okay, so here we have our program. So this main function is going to check, and it will pass 5 to the recursive function, which is total. So here total is now 5, and here we declared int a equals to 0, and then we check the condition. If x is equals to 1, in this instance, what is passed to x is what? Is 5. If 5 is equals to 1, then print out 5, which is x. But if not, we have declared a variable and we call it a, and we initialize it to be 0. We have said that a is equals to x, which is 5, plus total minus 1, which is x minus 1, and x minus 1 is 4. X minus 1 is 4, right? So if this is not true, then print this condition for us, which is 5 plus 4. Print that condition for us and check again and run this again. Is 4 equals to 1? If not, come back again and check. X is 4 plus 4 minus 1 equals 3. It will check this condition till it gets done. So let's do this now. Let's pick a marker. Oh, I didn't save that. I didn't save that. Okay, let me just quickly rush through this. Let me rush through this so that we don't waste too much time. Okay, so now let's continue. Now let's look at the stack of this particular program. Let's look at the stack now. Okay. Now, like I said, the main function is going to pass whatever the main function is holding, which is here 5. It passes to total, and total is now our recursive function, right? Now that means here our parameter is going to be 5. So we check the condition. If 5 is equals to 1, because x is 5 now, is 5 is equals to 1, return what? Return 5. But if it's not equals to 1, then enter the next condition. And what's the next condition? We've initialized a to be 0. The next condition is that a is equals to 5 plus total x minus 1. X minus 1 is 4. So that means is x plus 4. It will check that, and then it will return whatever the result is. Go back again into the loop and check. Now x is equals to 4. Is 4 equals to 1? No. 4 is not equals to 1, so it will leave here and it will come here. And this will now be 4 plus 4 minus 1. 4 minus 1 is 3, so that will be 4 plus 3. It will return the result. It will check again and add everything together till this condition is true. Then it will print the result for us. How do I mean? So this is total. My brush is okay. Let me check my other paint. Okay. So total. And here total is equals to 5 that is passed to it. Now total we check 5, enter the condition 5 plus sum of this, which is total, five minus 1. 5 minus 1 is equals to 4. So rather than writing it that way, let me just let's just write here 4 so that we don't waste a lot of space. So this is 4. it will go and check the next condition for you. Now, checking this condition, remember now, x is equals to 4. So here we have 4 plus total. 4 minus 1 now. 4 minus 1 is 3. So now total is 3. It will check again. Is 3 equals to 1? No. 3 plus so 3 minus 1 is 2. Three minus 1 is 2. So here it will be 2 plus 2 minus 1 is 1. It will check again. Here now, this is 1. So it will check and see if 1 is equals to 1, return S. So now it's going to return. So this condition no longer stands. It's going to return X. So return. Now it's going to return. So the condition goes back. Please pay attention. The condition goes back. Now it will check and add this together. So 2 plus 1 is equals to 3, right? This is 3. Return again and check. 3 plus 3 is what? 6. Return again to the next step and check. 6 plus 4 equals 10. Return again and check. 10 plus 5 equals 15. So it will print out 15 for us as our result. Right. So this is a simpler way of using recursion. But this also depends on the question you are asked to deal with. But this is a simpler way, especially if you are asked to deal with a stack in recursion where you know it has to print in reverse. So this is like printing it in reverse because it's stacked. So this is how you can run your program. So if we have, let's say we'll pass 6 now. We'll pass 6 here. So this is going to be 15 plus x, which is 6. It will print for you. You pass 7, it's going to be 7 plus 21. It will print it for you just like that. All right, so let's write this program in real time and see how this program will look like. Let's call this test2.c. Okay, so let's call our function and let's say total in total, and let's pass our parameter and give it parameter x. So this is our recursive function, and let's go ahead and create our main function, and let's just say this function is void. Okay, so here let's say int b, and then let's say b is equal to total, and let's pass 5 to it. Let's go ahead and print and print it. %d. Let's give it a new line. Okay, so we are done with our main function. Okay. Now let's initialize a variable we'll use. A equals to 0, right? And then here, let's give a condition and say if x is equals to 1, if x is equals to 1, return, just return x to us. If it's equals to 1, return x. But if not, let's just declare variable and say this will now be equals to x plus total x minus 1. Then let's return A. Okay. So this is exactly the same program we wrote here. Right. So let's run this program and see. Same thing, same explanation I just gave. It will check, total is 5. It will bring 5 here, and then it will check the condition. Is 5 equals to 1? If it's not, then it will enter this condition and check. So A, which is declared to 0, is equals to 5 plus 5 minus 1. Print it. It will check the condition again. Now, this is going to be 4. Is 4 equals to 1? No. It will come back and print 4 plus 4 minus 1 is 3. And then that will be 4 plus 3. Add it up. It will check again until x is equals to 1. So let's run this program and say gcc test2.c. Let's just pass this to A. Okay, so let's check our code and see. So here you see it printed 15 for us. Why is it 15? Because we passed 5, just like we explained. 15 because we pass 5 to it. So it will check 4 plus 4. All right, that is 5 minus 1. Come again and check. 4 minus 1 is 3. Come again and check 3 minus 2. And then it will, once it gets to where the condition is true, it will return the answers. Add it up, and then it will print it for you. So what happens if we pass, let's say we pass 6 to this function now. Rather than passing 5, if we pass 6, what is going to happen? If we pass 6 here, what is going to happen? Let's see. So that means it's going to print 6 plus 15, right? 6 plus 15. That's 21. So you see it printed 21 for us. So this is how you can use your recursive function, right? I believe this is clear enough. So in our next video, we're going to be looking at answering the questions and the tasks proper. Thank you for joining. Make sure to leave a comment if you find value, like our video, and you can also share. And if you've not subscribed, please do where to subscribe. That's the only way you can just help us as we give you value. Thank you for joining again, and see you in our next video.